Hello everyone, and welcome to our next lecture of this topic, context-free language and context-free grammar. I hope you got my previous lecture. Now let's start our next aspect. So let's start our discussion with what we are going to study in this lecture. We will going to start first of all with respect to review of our last lecture, and then we will continue from where we had left, that is uh, from grammar. In last lecture, we had started the introduction of context-free grammar and context-free language. For that, we had discussed the Chomsky hierarchy, where we had picked that context-free grammar or context-free language is superset of regular language. We had already picked what is regular language, and we had discussed all those stuff in our last class or last lecture, that how regular language is subset of context free. We had also picked that all the languages which are context free, it's not necessary that all are regular, but all the regular languages are also context free. So all those things we had done. We had picked the Chomsky hierarchy, and then we moved that for any language we require certain set of rules, and that is called grammar. We had picked that how to represent mathematically any grammar, and that is by using four tuples, that is variable, terminal, production, and starting symbol. We had also picked that how to write any specific grammar. So we had picked two different examples, and we have identified that if any grammar is written in mathematical term, then how to extract all four tuples, which are variable, terminal, production, and starting symbol. So all those things we had done in our last lecture. So what we are going to do in this lecture, what is next aspect? We had picked that what is grammar. We had identified few examples. We had also extracted tuples. So we are going to start with the same thing. We are going to start extraction of tuples, and then we will move into the next aspect, that is derivation of a string if any grammar is given. So let's see one example of grammar, and let's try to pick that how we are going to read it. In last class, we had picked that how to read any given grammar. What is this arrow sign means? So let's again read it. It says S produces small s a, small a and s. Here S produces small b s. S produces small c s, and S produces epsilon. Here epsilon is again having the same meaning which we have done in finite automata, that is null value. Now what does this mean by arrow? It says that S can be replaced by whatever value given here. That is, currently in this rule number 4, it is saying that null. So S can be replaced by null. In rule number 3, it says S can be replaced by small c and capital S. So this is how we read this thing. Now, in previous lecture, we had also done one thing, that is extraction of tuple. So there are four things: variable, terminal, production, and starting symbol. So can you extract all four tuples from it? I hope that you can easily extract. So tell me, what are different tuples here? So all four tuples, let's start with one by one, that is variable. Now how many variables we are having and what is variable? Variable, once again, it is whatever you got on the left side of this arrow, everything is known as variable. Here currently we have only one variable, that is capital S. Now terminals. In right hand side, remove all the variables which are written, that is S, S, S. If I'll remove all the variables, whatever left, all those things are terminals. So hence the left thing are A, B and C. Since we have one epsilon also, so it also here. Now what is P? P is production rules. Production rules means how many rules are given in the grammar. So here we have four rules which are given. Now please make sure once you are writing production rules, currently I had written only four here, but actually what you need to do, you need to write all four rules here to represent production rules. Now what is the starting symbol or starting variable? Which is the first rule by default will become starting rule, and the variable which is producing it is known as starting variable. So please make sure if nothing is given, I am repeating again, if nothing is given or mentioned, the first variable which is producing the first rule is known as starting variable. Currently in this grammar, since there is only one variable, hence we have no problem to for the identification of starting variable, that is S. Now I hope we can easily identify all the tuples from any given grammar. So let's move ahead and discuss our today's topic, that is derivation of a string or derivation of word. Now as you have already done string generation from any given finite automata, this is quite similar to the same thing which we had done earlier in finite automata. What we had done actually, if any finite automata is given, we can generate any string which will get accepted or rejected by that finite automata by traversing that finite automata. In the same manner, we are going to generate or derive any string from the given grammar. Now, what are the rules for it? So, here are few rules which are given. That is, as we have done in our finite automata, from where we had started our string generation, that is from starting state. Whatever we had the initial state, if I want to generate any string, I need to start from that initial state. Similarly, if you want to derive any string from any given grammar, you need to start from the starting variable. So identify the starting variable. Now the next step says that identify variables produced by the start variable. Identify that what is the production rule produced by that particular variable, which is my start variable, and identify what are other variables which are directly or indirectly produced by that starting variable. Then deploy the third rule, which says that find a variable a that is written down and a rule a produces alpha. if any variable you have identified, even it is a starting variable, suppose you got x produces capital A small b, and now you have identified that starting variable is producing one variable a on your right hand side, then pick what is produced by that particular a variable. And if it is a produces alpha, then replace the variable a with the string alpha. Now please make sure here I am not saying that alpha is only single alphabet. This can be any string, just like I have earlier said that suppose starting variable is producing x produces capital AB. So capital AB here represented by alpha. That's why I am saying it is string alpha. So replace that variable a with that string and repeat these two steps 3 and 4 continuously to generate your string or word. Now please make sure what will be actually word. Just like in your finite automata, what was the string? String was only combination of inputs. Similarly, here also string will be or word will be only and only combination of terminals. Hence, what actually you need to do from those rules, starting from starting variable, you need to derive or you need to convert those rules in such a format that it is only producing collection of terminals, and that will be known as string or word. So I hope you got that how to derive any word or any string from it. Let's take one example. Well, before going into any specific example, let's pick one more notation, and that is alpha is producing certain beta. Now, why we are using this arrow? Now, I hope you remember that once we have generated a string for regular uh, languages, that is for finite automata, and once we had accepted or rejected or proved that that particular string will get accepted or rejected by any given finite automata, we have showcased that thing by IDs, that is instantaneous descriptions. So we have utilized this particular thing. We provide rule number here, and on the basis of that we moved continuously, and in this way we moved one by one and showcase that whether any string will get accepted or rejected by any finite automata or not. Similarly, we are going to utilize this particular notation for representation or for derivation of any particular string from any given grammar. So let's start with the same example which we have taken earlier for deriving any specific string. Now, suppose I want to derive one string, that is W produces AACB. Now the thing is how to derive this string or how to generate this string. So as per our rule, it says that what we need to do, we need to start with our starting variable. Now, friends, be careful. It rule says that you need to start from starting variable. Now the thing is, starting variable is producing all the four rules. So from which rule I need to start? Most of the time, students get confused that instead of starting variable, starting rule is mandatory. So be careful. Rule only says that starting variable is mandatory for starting the production of a string. It never says that first rule which is produced by the starting variable is mandatory, or first rule whether it belongs to starting variable or not is mandatory. So be careful about it. So the thing is, if starting variable is producing multiple rule, so from which rule I should start? The answer lies on the string, and string always picked from left to right direction, which means the production always start from this thing. So currently string is A, C, B. So I know the first thing which will get produced, that is A. Now identify currently in this example that which particular rule starting from my starting variable S can provide me the first alphabet as A. So the answer is pretty clear that first rule fortunately is providing me A. So I am going to utilize my first rule which says give A S. Now once I got A, the next alphabet which I want, that is again A. So which rule I need to deploy again? So I got that there is only one rule, which is the first rule, which is providing me A. So I am again going to use this rule and replacing this S by this AS. Now similarly, now I got AA. Third thing which I want, that is C. So rule number 3 says that S is producing CS. So this S will get replaced by this CS. So I got finally AAC. Now the thing is, the last thing which I want, that is B. And B can be produced by rule number 2. But rule number 2 says that for production I require S is producing BS. Now, although I got AACB, but there is one extra S I am having. So how to remove this S? And here I am going to utilize the rule number 4 which says S is producing null. Means I can put up value null here and I can delete this S straight away. Hence, I only got string AACB. Now, as I told earlier, string is only a connection of terminals. So you can see it is only having terminal. So in this way, I can easily generate or derive any given string from any given grammar. Now, here you can see I have given this thing also. Then what is this thing? And is these two things are equal? The answer is yes. This is another way of representation of the same grammar. If one variable one variable is producing multiple rules, then in short form I can write this by using this OR operations. It says the same thing, that S is producing A. I think there is one S is missing. So S is producing AS, or S is producing BS, or S is producing CS, or S is producing epsilon. So all those four rules are in OR condition because all four are produced by S. Now here, please do correct, this is not only A, it is AS. So this is another way of representing the same thing. Now let's take another example. Here we got one more grammar which says S is produces A capital S capital B, B produces capital S small b, B produces small b, S produces small a. Now once again, this can be rewritten as S produces A as B slash A, means S produces A as B or S produces A. Rule number 1 and rule number 4 in combination written as this thing. And B produces SB slash B or SB or B, or B produces SB or B produces B, means rule number 2 and rule number 3. Now what are tuples in it? So once again, any grammar have four tuples: variable, terminal, production, starting symbol, VTPS. Now what are variables here? Here we have how many variables? One is S, one is B. Once again, on your left hand side of grammar, whatever symbols you are having, all are variables. So here we are having two symbols, that is capital S and capital B. Hence these two are variables. Now these two becomes variable. Now what are terminals? What are terminals here? Please make sure terminal is also known as non-variable. In some books you will find variable, non-variable, while in other you will find variable terminal. So don't get confused. So terminals, what are terminals? Remove all the variable from your right hand side and whatever is remaining, everything is terminal. So here small a and small b, small a small b. So we got our two terminals. Now what is starting variable? Starting variable is the first rule produced by that variable if nothing is given. Once again, if nothing is given explicitly, then first rule produced by the variable becomes my starting variable. Hence, S is my starting variable. Now, how many rules we are having? We are having four rules. If in this format it is written, then 1, 2, that is 3, and that is 4. In this way, all OR rules will be one rule each. So be careful once this format is given. So in this way we can identify all the four tuples: variable, terminal, production, starting symbol. Now let's try to derive one string or one word from the given particular grammar. Here I am taking one string triple A B. Now the thing is how to derive this particular string. So again I need to start from my starting variable which is S. Now which particular rule from which I need to start? I require triple AB. If I'll start with S produces A, I will not be able to grow my string further. Hence, although this rule number 4 is starting with my starting variable, I cannot start my string derivation from this particular rules. Hence, there is only one choice which is remaining, that is deploy rule number 4, which is small a, capital S, capital B. Now I got my A. Now there is AAB which I require. It means from SP I want double AB. Now how to convert it? So what I can do, I can utilize now rule number 4 which says S produces A. Hence from this I got my next A. So I got double A. Now from B I need to generate a B. So how to proceed with it? For that, for AB, that B can be straight away generated, and S, as we already know, can be produced by rule number 4. Hence, I have deployed rule number 2, which says SB is producing SB. Now, S, by deploying rule number 4, I got this. Hence, we are able to generate one particular string, that is triple AB. Now, from this, you can easily identify that generation of a string from any given grammar is a pure logical way for determining that which rule will be suitable for extraction of that particular string. It depends upon individual that how he or she is deploying rule. Now, there is a possibility that by using multiple ways I can generate any string. Yes, that is possible. It's not necessary that only one rule will get applicable to reach for any specific string. There can be multiple paths for it. So that's all from this lecture. In this lecture, what we had done, we had picked that how to derive any given string from any given grammar, how to proceed for it, how to extract it, that all those things we have done in this lecture. In next lecture, we are going to focus on that what is actually context-free grammar, and further we are going to extend our concept of derivation into more specific way, which is various derivation mechanism, LMD, RMD. So we are going to discuss all those stuff into our next lecture.